Hi, we are going to add and subtract rational expressions. All right, so we want to add 3 over n plus 4 plus 4n over 3n plus 3. The first thing you always have to do every time is if there's anything that could be factored in the denominators, you have to factor that first. You don't have to factor the numerators, but the denominators have to be factored, because that's how we're going to get the common denominator. So in this first fraction, the denominator can't be factored, it's just n plus 4, so I'm just going to leave it. But the second fraction, if I look at the denominator 3n plus 3, I could factor to 3. Okay, so now my denominators are factored, and then I'm going to look through the denominators and make sure both denominators have the same factors in them. I'm going to try to rewrite them so the denominators are the same. So if I look at this first fraction, n plus 4 is a factor, is the only factor in the denominator. If it makes it easier, put parentheses around it. So n plus 4 is a factor that sticks together. There is no n plus 4 in this fraction in the denominator, but I need there to be for the denominators to be the same. So I'm going to multiply n plus 4 in this denominator so that now they both have n plus 4. But whatever you multiply to the bottom, you have to also multiply to the top. Okay, and then there's a 3 in this denominator, but there's not a 3 by itself in this denominator, so I need there to be, so I'm going to multiply this denominator by 3, and I have to do that to the top as well. So now they're almost the same. They both have n plus 4. This one has a 3 times 3. This one has a times 3. But now this one has an n plus 1, and the first one doesn't. And I need there to be an n plus 1. So I'm going to multiply by n plus 1 on the top and the bottom. Okay, so now in the denominators, they each have a 3. They each have an n plus 4. And they each have a times n plus 1. So now we have two fractions with a common denominator. When I rewrite the numerators, I need to distribute, because we're going to have to add the numerators together and combine like terms. So the numerators need to be distributed. There's 3 times 3 times n plus 1. So 3 times 3 is 9. So it's basically 9 times n plus 1, which is 9n plus 9. And then for the other fraction, 4n times n plus 4, 4n squared plus 16n. And now I can add the two fractions together. They have common denominators. I can add the numerators together, and the denominator stays the same. When you add two fractions together, you need a common denominator, and once you add them, that is the denominator. You just add the numerators together. So I'm looking for like terms that I can combine together in the numerators. So I have 9n plus 9 plus 4n squared plus 16n. So there's a 4n squared. I'm going to add the n terms together. 9n and 16n is 25n. And then there's just the 9 by itself that can't combine with anything else. The only thing I still need to check for is to see if this numerator can now be factored, just in case there's a common factor in the numerator and denominator that can cancel out. So if I'm trying to factor that numerator, I'd put 36 in the numerator, a times c, 4 times 9, 36. I'd put 36 on top, 25 on the bottom, and then I'd be trying to think of two numbers that multiply to get 36 and add to get 25. So I'm just going to kind of go through 1 times 36. That won't work because there's no way to combine those two numbers to get 25. Okay, so there's no way to combine any of those factors of 36, those factored pairs, to get 25. So this can't be factored anymore. We're done. I'm just going to leave it like that. All right, let's try this other example. So we're subtracting these two fractions. Again, we're going to want to start with factoring the denominators. In this first denominator, I can factor out a 2. And in the second denominator, it's a quadratic. I need two numbers that multiply to get 3 and add to get 4. 3 times 1, so x plus 3, x plus 1. The reason I could skip the whole area model is because it's just a 1x squared. Whatever I get for these numbers, the 3 and the 1, I could just plug in straight to my factors. Okay, so what's nice is these denominators already have an x plus 3 in common. They both have x plus 3, so I can just leave those there. But this one has a 2 by itself, a times 2, and this other denominator doesn't. So I need to multiply the other denominator by 2. I'll put times 2, and then same thing, I have to multiply it to the top as well. And then also this denominator has an x plus 1 that the other one doesn't. So now they both have a 2, they both have an x plus 3, but then this one has an x plus 1. The first denominator needs an x plus 1, so I'm going to multiply x plus 1. All right, so now I'm going to rewrite what I have. Both denominators have 2, x plus 3, x plus 1. In this first denominator, we want to write what we have, but we're going to distribute. I'm going to multiply x times x plus 1. X squared plus x. And then same thing here, I want to distribute the 2. So 2 times x minus 2, 2x minus 4. Okay, so now I have a common denominator. I'm going to subtract the numerators. We have to be really careful because we're subtracting this whole other numerator. So we're going to have to distribute the minus sign. I'm just going to go ahead and rewrite the denominator because the denominator stays the same. And then x squared plus x minus 2x minus 4. So if I'm combining like terms, there's just x squared, there's no other x squareds, so just x squared. I have an x minus 2x, so that's a negative x. And then there's this minus 4, but this subtraction sign is going to distribute. We're subtracting negative 4, so it's going to become plus 4. And then just like the last problem, the last thing I want to do is see if I can factor more. So if I'm looking at the numerator, x squared minus x plus 4, if I was going to try to factor that more, I would be trying to think of two numbers that multiply to get positive 4 and add to get negative 1. The only thing that's things that multiply to get 4 are 1 and 4, and there's no way to combine those to get a negative 1 and 2 times 2. So not factorable. We always want to double check though, and then this would be our solution.